All right, so let's continue. Let's wrap up this problem here. So for finding C, what we're going to do is we're going to multiply by s plus 3 on both sides, of course. That causes the s plus 3's to cancel on the left, causes the s plus 3's to cancel on the right for the C term. And so if we rewrite this, it'd be s minus 1, s minus 3. And on the bottom, it'd be s times s plus 1. That's going to be equal to, let me clean some of this up. Got some extra mess here. That's going to be equal to a times s plus 3 over s plus b times s plus 3 over s plus 1 plus c. And what are we going to evaluate here? Hopefully everybody knows by now we want to evaluate at the value that's going to get rid of these two terms. And that's s equals negative 3. Because that's going to cause this to go to 0 and this to go to 0. All right, and so we're left with C is basically equal to this left side evaluated at negative 3. And let's take a look. It's negative 3 minus 3 is negative 6. Negative 3 minus 1 is negative 4, so that gives me 24 in the numerator. And I got negative 3 plus 1 times negative 3 in the denominator. Sorry, I'm trying to do all this in my head. Negative 3 plus 1 times negative 3, that gives me a positive 6. So I had 24 on the numerator, 6 on the denominator. That's going to give me a value of 4, and that's correct. So C is 4. Hopefully everyone is clear. I know I'm doing this all in my head, but basically what I just did is I just said, okay, so I'm plugging in negative 3 for S everywhere. Negative 3 times negative 3 plus 1, and I just determined negative 3 minus 1 is negative 4. Negative 3 minus 3 is negative 6, so that gives me 24. And I get negative 3 times negative 2 on the bottom. That gives me negative 24 over negative 6, which gives me 4. That's how I've been doing this whole time. Hopefully that was clear. So now I've got my 3 terms that I have found, and I have completed my partial fraction expansion here. And so I could rewrite this f of s, right? My original f of s, which was this ugly looking thing, I could rewrite it as 1 over s. Hopefully we already know that. That would transform to u of t. Plus, or I guess we could just write minus 4 over s plus 1 plus 4 over s plus 3. And now this would be very easy to take the Laplace transform of. Right? All we would have to do now is go term by term. I already did the first one for us. It's u of t. Let's do the other two. Why not? We already have that accessible to us here. This is the Laplace transform pair that we're interested in. So I'll just throw that in here. And so if we wanted to write f of t, it would just be u of t minus 4e to the minus t u of t, and then plus 4e to the minus 3t u of t. That would be our function f of t after we take the inverse Laplace transform of each of these individual terms here. All right, so that wraps up this example on partial fraction expansion. We're going to use this in solving problems. So hopefully, I know it looks like a lot of math here, but hopefully you see that it's a pretty straightforward process. And yeah, I'm going to wrap up this video here. I'll see you guys in the next video, and we're going to solve some example problems actually using circuits. All right, so we'll see you in the next video.